Today, welcome, ladies and gentlemen. We're going to start our unit, about 4 to 5 units, and we'll be going through. Say hippie hoppy hippie head. Yeah, excited. Let's go for a fun. How the heck? Oh, that's the ear. Those look like horns. But then that's the outside of the ear, which now I can see as a wolf. I thought it was a wolf. Maybe it's a goat. I'll be better. So, okay. So 1-7 today, which is the rational root theorem, and to start rule of sign. And Ethan's like, what? Well, we're going to learn about, guys, you know about the rational root theorem? Ooh. Say again, I'm sorry. Not that I am aware of, my dear friend. No. If you so choose wanting to choose life there, sure. All right.
What was the name of it again?
Possible rational roots. We'll get to it. 1-7. You have to go old school. Go on the whiteboard.
Old school.
1-7. Possible rational roots. Okay, I'm going to write one up here just so you guys can get the middle. So if I have f of x equals this lady in the back, help me name again. Olivia. Oh, I know you. Olivia. Oh, Maya. Maya, you will learn a foreign language here. It's called Robert E. and you'll get used to it. Maybe you won't. That's actually not too bad at handwriting. Okay, so let me ask you guys this question. I want you guys to find the zeros of this without using your calculator. Can we do so?
Yeah.
How? Does it factor? No. We've only been taught how to factor things that are factored by grouping. Notice if I factor my grouping plus no, I'll show you. Well, I mixed squared up of x minus 5. What do these guys say? That's 2. X minus, x plus 4. Are these the same? So can I factor? That's the only way I've learned how to do these, except for some are different from 2, right? Is it either of those? So, Tuttle, Ducks, and Tinkerwinks, what are we going to do? That's true. Well, in a way. What do you think? Well, that means half your life right there. How many zeros are there? We have, whoa. Not 3, 2, 6 at all, just 3. Okay, we have 3 zeros, agree? Because of him. Okay? Now, what kind of zeros could that be? Notice I could have 1 0, something like that. What else could I have? How about 2 zeros? Where it only hits the axis twice. Check that. Notice I crossed one here in that basket, so that means we have 2. So that's technically 3 zeros, because I have 2, but at the same point on the other one. So I agree, that's 3 zeros. And then I could have 3 choices by going, party brother. Live in the American freaking dream. You as well. Hey, notice those are choices. Notice this one crosses at 1. And this one would not be an x2. It would be like x minus 2, because that doesn't fit that over. So notice I'd have 1 crossing here, which I could also have 2 imaginary solutions. 1 real, 2 imaginary, does that add up to 3? Those are still not. Okay, so I'm going to take this formula, the equation again. Tell me again if there was x cubed Minus 5x squared. Okay, now I do know there's 3 zeros, and even if they are imaginary zeros, I can still write those as a linear factor. Okay? That's a big hip on the butt, right? Emma, why are you all sticking up? You're no longer a baby? No longer the marcher that no. Take the parodic side. The Leah did really good on our test. Good job. Good job. I'm not going to mention how about that. You do rather, no offense, rather. You get there, you can go. By the way, sorry, you didn't back up that. Okay. For me to be x cubed, what needs to be here? X. 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 X cubed. You guys agree with me now? What is the possibility that this guy he can go here, right? Give me a possibility that he goes here. I have 3 things. So it's 8. 2, 2, 2. Okay, that's the one. 2, 2, 2. I know that was not right because that was the here. How about plus 1, a plus 2, and a plus 4? Is that a possibility? Yeah. Positive 1 times a positive 2 times a positive 4 gets you to be 8. That's a possibility, isn't it? What else is a possibility? Anyone else want to help me? I could have a negative 1 even, a negative 1 and a positive 8, couldn't I? All those multiply to get that, don't they? Any other situation? Even this one, I could do negative 1, negative 2, and 4, or I could do negative 1, negative 2, and 2. So many options within even the 3 values that I have. Well, a little bit. Okay? So, but if you'll notice, these numbers are what? These numbers are factors of 2, of the constants, aren't they? Okay? What are these numbers? They're factors of the leading coefficient, are they not? So that's where the rational root theorem comes in. We're actually looking for the possible rational root. It's called the rational root theorem. Did I talk about it before? I could have, maybe. I don't know. Okay. Where did we find the possible rational roots? Here we go, ladies and gentlemen. Notice, when I solve these type of equations, let's look at this guy. What are my zeros of that guy? Negative 1 divided by 1. Negative 2 divided by 1. Negative 4 divided by 1. Right, those would be my zeros. You guys agree with me on that? Well, notice those possible rational zeros come from the factors of the constant divided by the factors of the leading coefficient. That is our possible rational root. or zeros. So who are my factors of my constant? Who was my constant? What number? 8. Who was that? What are factors of 8? 1, 2, 4, 8, right? But notice, did I show that I can be negative with any of those values? Yeah. So I think we need to be plus or minus of all these values. Not only do the one that we said we need plus or minus for everything. In my case, I don't do it for every single one. Okay, who's my factors of my leading coefficient? 1, so it's plus or minus 1. So what are the possibilities? Well, here I go. Here we go. What's 1 divided by 1? 2 divided by 1, 4 divided by 1, 8 divided by 1. 1, 2, 4, 9. You agree? So how many choices do I have for a possible rational zero? 8. How do I have 8? I have 1, 2, 3, 4, negative 1, negative 2, negative 4, negative 2. Does that make sense? Agree with me there? All right, let's see if we can find this factor, this kind of a monkey jumble. Those people at home, okay, here we go. So what's the coefficient? What did I have? 1, negative 5, right? 4 and 8, or 2 and 8? Somebody tell me. You look so enthused. You could ever, we don't get it. We're gonna blame you. Out of plus or minus 1, 2, 4, 8, pick any number and tell me something that's right. Pick any of these numbers. 2. She wants to try 2. Let's try. Are you always going to find something that works the very first time? Let's see if she's a good person or a scallywag. Here we go. You're a scallywag. You got it right. How do I know that this works? Because it has no remainder. That means it is a factor, huh? That feeling just was like chucking it out there and hopefully it worked, and it did. Are you going to be able to get it always on your first shot? No. There's one that we had today that we tried that had 30 options. This one only has 8. And we didn't find it after 4 of them. But it took a while. Okay? But nice thing, we tried it. Hippy hoppy, hippy hoppy. Hey, we're excited. Okay? Notice though, this was x cubed. What's this? X squared, right? Because once again, we divide it by that foot only. So therefore, this comes out to be, hey, what you doing, Mr. Berkeley? Are you checking my ears out, or are you checking my hair on my ears? Oh. Are you talking about the, do you want to see the blue dot on my hair? Wait, you see it? Oh, about a green, about a blue? Yeah. Oh, is that your dot change? No, that's my permanent dot change. I used to always tell people that besides the football thing anymore. I remember growing up there like red dot, blue dot, blue dot. I'm like, I want blue dot. So everybody has one. Have I done a dot change in here yet? Yeah. Is your goggles as thick as your glasses? I love it. Your brother. Okay.
Why are there 3 dots?
I don't know. Okay. What do we always here? This is what? Quadratic speed. I can do. 1. Quadratic formula. 2. I'm the tractor. Tractor, oh my goodness, I don't know how you guys got that. Shut your mouth. Okay? Factoring. Okay? So this guy, I personally will always factor if I can. Can this factor? It does. Factor the 4 and the 3. -4 and 1. Who is also one of my guys at work?
2.
2. So notice if they ever ask you to put it in linear pairs, this is what linear pairs is. Well, what are my zeros? Because that's what I was looking for. We have -2, 4, -. Okay, go ahead, Mark.
Where did you get the trinomial from the quad?
Okay, so remember, anytime that I do simple division, remember I'm dividing by x -2 or something, right? So how many times can x go into x2? X squared stuff. Remember, you always go down 1 degree.
Oh, okay, so it's just product of that.
So if I times this, x -2 times this, I should be able to. Oh, just like that. Everybody understand what the question was? I was today going to go down 1 degree. What is this? What would this be? X to the 4th, because it always goes down 1 degree, right? And you do things better. With me? Yes, no, maybe so?
Yeah.
All right. Okay, I'd like to, by the way, do you know what rational roots are? What's a rational number? Anybody remember the definition of rational? What do you got for it, Bella? Okay, so a decimal that is or repeated, or what can we always do with those numbers? Make them into fractions. It's a number that can be written into a fraction. That's really what a rational. Whereas to is not, that's an irrational. So notice, guys, could there be zeros in a polynomial that are irrational that I can't find? Sure there are. I actually did one today with students, but I had no idea. I picked one off this paper and it was not fun. You pick like 5 numbers, we're like, screw it, let's find them on a calculator and they came up to be irrational. It sucks. But it is what it is. Okay? So these are just possible rational numbers. Does every function come out with a rational number? No, I want you to be aware of that. The ones that are on your test. Thank you, David. By the way, I just been explaining this to everybody else. You guys know how a repeating decimal becomes? Anybody know? You guys ready? Give me a number that's repeated decimal. 0.338, so that's a third, right? So we already know it's a third, which is 0.3333, keeps going, but I don't want to keep going.
You have to pin down.
Huh?
You have to pin down.
I'm going to call him F. So, just for curiosity about this, guys, how many times do I need to move my decimal to get past the repeated? 1. I just need to move it 1. So I'm going to times it by 10, because moving my decimal once is times it by 10, right? So I'm going to times this by 10. I'm going to times this by 10. What happens if I go 10x minus x? What do I get? 9x. That means 3.33333 minus 0.33333 is 3.
Whoa. That's incredible.
Have you ever seen that before? This is also the same way how you can say 0.999 repeating as the same thing as 1. Ready for this? How many times do you have to move it? What? Subtract it.
Whoa.
That's a proof to say that x is equal to 1. 0.99999. Kind of interesting to think about, isn't it? Anyway, onward. I just wanted to show you guys so you guys understand, because sometimes why does repeating decimal become able to be written as this? It never stops. How is it? Because of subtraction is like it always is. That makes sense. All right, so I'd like to use the same example, but I'd like to talk think that's how you say it. Anybody that has a cool language know how to say that? Just start kidding. Okay, what the chart rule of science tells us is this. It tells us whether or not, or not whether or not, it tells us how many zeros are positive and how many zeros are negative. In our last example, look at the answers you guys received. How many of those zeros that we found at the end, how many of them were positive? One. How many of them were negative? Two. I'm going to show you how we can find that before I even found it. Okay. Here we go. What was it again? X cubed minus 5x squared plus 2x plus 8. Okay. Okay. I'm going to show you how this works. So what you do is we have our normal equation that they give us. Okay, and what we're looking for is how many sign changes are there? What I mean by a sign change, I'm looking at their coefficients, and as I go down 1 degree, are they changing value? Does that make sense what I just said? So, notice what's my leading coefficient. He is a positive 1. Tyler, you're killing me, man. I have a positive 1. How does 1 get to negative 5? Notice that is a sign change, is it not? Notice I went positive to a negative. Does everybody understand what I mean by a sign change here? Does negative 5 to 2 sign change? Do I have any other sign changes? Okay. By the way, what were my zeros again? 1, negative 4, and 2. Okay, good. Because I thought I was wrong. Anyway, that's the only time, because right here, do they sign change? Positive to a positive, is that a sign change? No. So how many sign changes were there? 2. So that tells us 2 or 0 positive zeros. Now you might be saying, where does the 0 come in? I'm going to explain that in just a moment for me, okay? Give me 1 second, I'll explain that. But all you have to do is look at the number of sign changes and it's 2. What if it was 4 sign changes? What would be my result? It'd be 4, 2, or 0. What if it was 3? 3 or 1. I'm going down by increments of 2, and I'll explain that in just one moment. Okay? Now, for us to find the negative, what I need to do is replace x with negative x. What do we get? Negative x cubed, which comes out to be negative x cubed, right? Minus 5, negative x squared, comes out to be negative 5x squared. 2 times negative x comes out to be negative 2x, and then I have my plus 8. Okay, looking at this adventure right now, how many sign changes? 1 sign change. So that tells us we have 1 negative 0. Descartes' rule of signs tells us the possibility of zeros, whether they're positive or negative. Now, what is that 0 doing there? What did we end up with? We ended up with 2 positive and 1 negative. Didn't that add up to be 3? Yes, no? 2 positive, 1 negative, that's 3 total zeros. What if I have 1 negative and 0 positive? Where's my other 2 zeros? They're imaginary. And what do we always know about imaginary numbers? How do they come? They come in conjugate pairs, right? If 1 plus I is a 0, who else is? 1 minus I. Conjugate pair. Okay? Yes, no? Does that make sense why it goes down by 2? Because there's conjugate pairs, they're always going to group into 2. Okay? All right. So, that's called Descartes' rule of sign. I usually try to do that before I even search anything, and I'll show you the reason why on this next example. Because once again, how many choices did we have at the very beginning? We had 8 choices to choose from. And Kaylin was just really not lucky and she freaking picked a good one, didn't you? But what if you didn't? Then you got to keep trying. But as soon as I found one negative value, I know I wouldn't pick any more negatives anymore. Why? Because there's only one negative 0. I wouldn't try any more negatives. You see how that could be helpful if you're trying to look through some more? You wouldn't have to choose any more negative values because you've already found the one negative. What if you found one positive? What does that tell us? Then I need to at least go try to find one more because there's 2 of them out there, isn't there? See how that can help us? Choosing. Okay. All right. We're going to do this example really quick. I always like to start with Descartes' rule of signs very first. That's actually the first thing I do before I even do my possible rational zeros. Okay, because it's going to help me. I guess we could start with our possible rational zeros. Let's do that. Possible rational zeros. Pros. Made that up today. No, earlier today. What is zeros have an ES or is it just F? Yeah, why is it either way? Whoa. Yeah, it could be either way though, right? Colors? They use a U? Weirdos over there. Darn people that don't like to protect their teeth. What? There. Oh. Okay. Let's do our possible rational zeros. Remember, who goes on top? The possible what? The factors of who? The constant. Do you guys understand why it's the constant on top, or do I need to explain that to you? I'll get there after we're done, okay? Here we go. What is our factors of our constant? Plus or minus 1. Then we divide by the possibilities of who? Of our leading coefficient, which is 2, which is plus or minus 1 and 2. So what are my options for my possible rational zero? Plus or minus 1 and 1/2. And the reason being is I go 1 divided by 1, 1. 1 divided by 2 is the half. Okay, let me explain really quick why. That those are the reasons why we do it this over this. Okay, just as we did in the past one, what has to be leading here? Is it just this time XXX? Is it XXX? Is X times X times X give me 2X squared cubed? One of them has to have a 2 in them, don't they? You guys agree with that? And then what does the 3 have to be? I could have -1, positive 1, couldn't I? Or I could do +1, +1, +1. You guys agree with that? So I'll just do +1s. Notice though, when I solve this, right here, what's the value? -1 divided by 1, huh? Factor of my constant divided by a factor of my coefficient. Factor of my constant divided by a factor of my coefficient. Factor of my constant divided by a factor of my leading coefficient. That is why you're doing this over this. because it tells you this is a factor of my leading coefficient. That's why it's going to be on the denominator, because I'd subtract 1 then divide by 2, wouldn't I? Does that make sense why you do it that over that? Why you do the constant divided by the leading coefficient? Okay? Ladies and gentlemen, here's my zeros. Well, possible rational zeros. Sorry about that, actually. Okay? Once again, it was 2x squared plus 5, cubed, plus 5x squared plus 4x minus 1. Okay? Let's talk about, just start through the signs. How many zeros? How many positive zeros are there going to be? How do I tell the positive zeros? I see if there's any sign changes of the regular. Is there any sign changes? No, there's none. Oh, sorry, this should be a +1. Whew, I'm going to say this one should be no. Sorry, I miswrote that. Thank you, Mr. Templeton. That was correct at that time. Thank you, Hallie. That was correct at that time. But now, do I have any? So what does that tell us? There are 0 positive zeros. How is that useful, ladies and gentlemen? How could that help us in our choice selection? Go ahead, quick. Instead of doing plus or minus, now I only have the choices of -1/2 and -1. That just cut our factors in half. In those cases that where I might have 30 choices, if I had 0 positives, I'm shouting hooray. That just got rid of 15 of them. Right? You see how that can be useful. Okay? How many negative zeros are there? Well, let's check. This is really how I do it in my process, by the way. Okay, this is an x cubed. If I place a negative x into negative x cubed, is he going to change? He is. He's going to come out to be -2x cubed. X squared, is he ever going to change? Because a negative times a negative in an even power is not, right? Is he going to change? Because he's an odd power. Is he going to change? Okay, so how many sign changes are there? 1, 2, 3. So what's my possibility? 3 or 1 negative zeros. Okay. So that does help me, because now when I go ahead and do synthetic right now, which is 2, 5, 4, 1. My choices were, if you recall from up above on your paper, what's my rational roots possibilities? Plus or minus 1, plus or minus 1/2, correct? But notice I got rid of the plus, so it's actually just -1/2 and -1. Agree? Which one do we want to try? I would always do -1 over -1/2 because I don't want to put it in the fraction. Right? Okay, here we go, -1. What do we get? Oops, sorry. Nope, that's wrong. Two. Then what do we do? Multiply. Add. Multiply. Add. Multiply. Add. We just narrowed our choices down to 2, and the one I picked was really easy. So this was once again an x cubed, right? So what's this guy? X squared. We always want to get down to an x squared, because if I get down to an x squared, I can always quadratic formula or factor it, right? One or the other. Okay, so this is a 2x squared plus 3x plus 1. Does he factor? Factors of 2 that get me to be 3. 1 and 2, right? who was our other guy? So what does that mean? We had a multiplicity, didn't we? Did you guys see how it's the same guy? Dude, what's my zeros? -1, -0.5, and -1 again. So how many zeros do I have? 3. How many are negative? 3. Isn't that the possibility that I could have had? Yeah, come check that out. Pretty cool, huh? You're confused? 3 0? Well, first off, this guy factored into these guys. You with me there? But this guy is right here. Because I already know he's a factor because he became 0 remainder. Does that make sense? Say again? Well, because remember, this is the value, but remember when we do synthetic, this is the value that made him 0, so yes, I got to put him over here. Remember, add him over, because that's the value that made him 0. Remember that? No. You know, but remember in synthetic, we always divide by the value that made the binomial 0. So what's the value that makes this binomial 0? -1. That's what I would divide by. Because that was part of the rule of synthetic, right? Okay. Should we try one more? Then we'll do another one, and then we should be good. Okay, let's look at this hippy hoppy, hey. Ooh. This is the one that has 30 possibilities. And we're going to find all 30. How's the drama? Ready? Are you going to theater? No. What the hell, man? Oh. Darn, what's being next year. All right, here we go. Let's do our rational groups, possible rational groups. So I'm going to look at my constant. What's my factors of my constant? Plus or minus 1, 2, 4, right? Divided by who? Factors of my leading coefficient, which is 36. So who's the factors of 36? Is 1, 2, 3, 4, 6, 8, no, not 8, sorry, 9, 12, 18, 36. Holy schnikers there, huh? Now I got to take each individual one of these numbers and divide it by each of these individual numbers. Woohoo! So here we go. 1 divided by 1. 1. 2 divided by 1. 2. 4 divided by 1. 4. Does everybody understand where I got those first 3? What's the next one? 1/2. 1 and 2. Do I need to rewrite those again? Nope. Let's go with the 3. 1 divided by 3. 2 divided by 3. 4 divided by 3. That guy just added 3 of them. How about 4? 1 divided by 4. 2 divided by 4. 1/2. Don't we already have him on there? 4 divided by 4. 1, and he's already up there as well, correct? Does everybody understand what I'm doing here? I'm taking every one of these numbers and going, these numbers divided by that. So I got 1 divided by 6, which is 1/6. 2 divided by 6, which is 1/3, which is already there. 4 divided by 6, which is 2/3, which is already there. Okay, let's do 9. 1/9, 2/9, 4/9. Holy crap, we're still going. 1/12. How about 2/12? He's already up there, isn't he? 4/12. He's already up there, isn't he? Okay, now we're going to do 18. 1/18. 2/18. 1/9, he's already up there. 4/18. That's 2/9. He already up there? He is. Let's go 36. 1/36. 2/36. 1/18. 3/36. 1/12. I'm done. How many possibilities are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times by 2. There's 30 freaking choices. Have fun. Go at it. Try it. No, I'm not going to do that. Okay. But there's some things on here that might narrow our choices. What can we do? Black magic. Awesome. That's just called Descartes' rule of sign. Okay, let's check it. Descartes' rule of signs. How many sign changes do we have? Right now we have one sign change. Does everybody see that's one sign change right there? So that means I have one positive 0. Okay, is he going to change or stay the same? Change, so I'm just going to do a negative. Is he change or stay the same? Stays the same. Because remember, what am I doing to do whether I'm changing or staying? I'm replacing x with negative x. Stay the same or change? Change. Stay the same or change? Same. So notice I have 1, 2 sign changes. So I'll have 1 positive 0 and 2 or 0 negative zeros. Now how is that helpful to us? We still got to find a positive. We still got to find 2 at most negatives, right? But if I find 1 positive, do I have to search anymore?
No.
That's it. Can I show you guys some? How many of you guys want to go synthetic and try start plugging those suckers in? Anybody want to give a guess at one? Just I'm going to tell you whether it now if it's right or wrong. 4 was very close. Huh? 1/4 is not. 6 is not. 1/2 is not. I've done this before, so that's why. Okay, here we go. Nope. Okay, I'm going to bring him down here, guys, just so you guys can see. Once again, it was 36x cubed plus 144x squared minus x minus 4, correct? What do these guys have in common? They have a 36x squared in common. What's left over? What do these guys have in common? We could factor by grouping. If you can factor by grouping, why the hell would you ever guess? You know what I mean? Look for those. See if you can factor by grouping. And this one did, didn't it? What does this come out to be? Called a difference of. And what does difference of squares come out to be? Conjugate pair. So that comes out to be 6x minus 1. And so what was one of them? Who said 4, by the way? It was negative 4. 1/6. Negative 1/6. All those were possible rational roots, weren't they? Notice what are my zeros of this? I'll help you out just by looking it up. Does that help you back there? So my zeros are negative 4, 1/6, and okay, really quickly, ladies and gentlemen, how many zeros are negative? 2. How many are positive? 1. Does that add up to be the possibilities that we said at the beginning? Kind of cool that it does, doesn't it? You guys want me to check that it works with one of these numbers using synthetic, or are you okay?
I believe you.
You guys good?
Yeah.
Okay. Now, so far, we've picked ones that always came out to be nice factors again, haven't we? Are they all going to be nice factors every time? No. No. Did I tell you who Betsy was? Who is it? Betsy is an open breed. She is my dead horse. Send her on to the dog food factory.
That's the guy.
She didn't. They shot her and they cut her up with dog food problem. She was going to die anyway. Huh? She foundered. You know what foundered is? Anybody know what foundered is? You do, Kaylin? Yes, I'm ready for you. On the last one. I could have factored it, but I'm just showing you, because once again, what is our big goal today? Learning those possible rational zeros. It depends on if I ask you for the possible rational zeros. Because I could ask you, what are possible rationals? Just to see if you understand the concept of it. But if I was asking just for the zeros, would I have to? Now, would I might need to find them if it didn't factor nicely? Does that make sense? Answer all your questions? Okay, ladies and gentlemen, let's find our possible rational zeros. Let's let you try on your own. Find your possible rational zeros. It'd be a pretty quick thing. Not our positive or negative zeros, our possible rational zeros. Did you find him, Liv? Okay, I'll give you just a second. Yep, hooray! Almost time to get out of here. Oh, that's a good one. So you run. Almost today. Hooray! Ethan, what do you play? Ooh, the sexy. The one that all has the sexy sound out of it. Is that awkward? All right. Okay, you should have enough time by then. Hey, go ahead, Miss Olivia. What did you get for my factors up top? Who goes on top? 27? Did you say 27 or 7? Everybody understand that? Because once again, that's the factors of the constant. How about the bottom? Which is then who? Plus or minus 1, 3, 9, 27. How many options do we have? 8. Can we pick it right out of the jar? Can anybody do it, you think? Or are we going to mess up? Nope, nope, nope. You can't try it. Notice. Huh? Let's try 9. Let's try 9. You forgot your 0. How many forgot their zeros when they tried synthetic? You got to remember your placeholder, right? You notice there was no x squared, correct? Okay. 9, 9, 81. Whoa, big A number. 27 plus 5, 45, 67. Definitely not a 0, huh? But it's okay. We haven't picked one that we didn't see that it didn't work yet, correct? Does everybody agree with that? Okay, so what do? We just keep trying. Let's try another one. Maybe know another one you want to try. 1? I heard 1. It is 3, actually. 1, 3, 3, 9, -9, -27, 0. Hey!
Yeah.
But notice, this is the first time it doesn't come into something nice. Factors of 9 that give me to be 3. 3 and 3, nope, that gets me to be 0. And 9 and 1 get me to be 8, so it doesn't work. So where do we have to go? We only have one choice. We go to a quad, right? Here we go. X equals -b plus or minus square root of b squared minus 4 times 1 times -9, which is 36, which is, hold on, we're not there yet. All over 2a, which is 2. What's the square root of 45, though? -3 plus or minus 3 root 5 all over 2. There's 2 of my zeros. Who's my other guy? 3. There's my 3 zeros. Are they imaginaries? They're irrationals, aren't they? So notice I should have something there. If I could discard 2 little signs, and I would have 2 positive and 1 negative. Let's see if I do. There's 1 positive. -3 plus 3 root 5. That's a positive number over a positive number. So there's my other one. -3 minus 3 root 5. That's negative over a positive, which is a. So I have 2 positives, 1 negative. How would I write him as a product of linear pairs? Pretty easy. How would I write him? What's the other one? Here we go. I'll show you. X. How do I get that 3 over? Add. How do I get rid of that plus up here? Minus it. All over 2. Not him. Then I have x plus 3 plus 3 root 5 all over 2. Now somebody said, Mr. Roberts, why would I not just times the 2 over and make it 2x plus 3 minus 3 root 5? Can anybody tell me why? Because if I put those 2 here, I'd have x times 2x, which is 2x squared times 2x again, 4x cubed, and what did we start with? X cubed. So that's why I don't put him up there. Does that make sense? All right. Do we feel good about the subject of finding zeros using our rational root theorem or using our discard rule of sign? Can I ask you a question? What if it didn't work a couple times? Okay, let's say your information come out that you got 1 comma -3. Because remember, even if it doesn't work, it's still something important. Why? Because if remember, the remainder comes out and it's negative. Okay, so I have 1 comma negative. What did that happen when I picked the 9? Didn't it come out huge?
Yeah.
9 comma 554 or something like that. What do we know about these two? How is that still good information? Anybody want to help me there? It's actually really good.
No, that yes, I have to be become now.
We know that there has to be a 0 between 1 or 9. How do we know that? Does it have to be a rational number, though? No. So I do know there's a 0, because think about this. Aren't these points that are on my graph? 1, -3 is here, 9, freaking that big number's up there, and they're going to connect, aren't they? So when they're going to connect, in between there, they cross. So even things that don't work are still good information, because if you can find 1 positive and 1 negative, that's called the intermediate value theorem, meaning I can cut that down in and I'll know there's a 0 in between there. Does that make sense? You cut down your choice. Right? You ever understand how that's important? We had to get to one that did, because you guys picked really good ones. Okay? All right, this is our last example for the day. All right, last example. If I gave you a 0 as 3 and 1 minus I, all right? I would like to write a polynomial with those zeros. What degree should that polynomial be? I have 2 zeros, so shouldn't it be x squared? Why not, Teresa? He should have a buddy, shouldn't he? Who should be his buddy? We also know 1 plus I should be here. Even though he didn't write it, we know he's there. Because, once again, imaginaries come with conjugate pairs. What if I gave you 1 plus root 3? Who else comes along? 1 minus root 3. Because anytime I personally take a square root, I would have had to do plus or minus. Correct? The answer why is do conjugate pairs? Okay, so this should be a degree what? 3. So how do I do so? What's this guy? This is very similar to what we had on our test, wasn't it? I gave you the zeros, write a polynomial. X minus 1 plus I. Does everybody understand how I got that? X minus 1 minus I. Does everybody understand where those linear factors come from? If not, that's where you guys got to come in. I hear one yes. Some people shaking their head, that's awesome. But if you don't understand and you're not mentioning it to me, that's on you. Okay? Make sure you're talking. That's your knowledge. You got to be aware of your knowledge and understanding where it comes from. Okay, so what are we going to multiply first? Leah, what will you do first? I'd do the last two. I'd get rid of those suckers with i's. Because if they're conjugate pairs, I'll get rid of the i's. Okay? Because what's x times x? X squared. What's x times negative 1? Negative x. X times negative I. Negative ix. That's the first one. Here we go. Let's do the next one. Negative 1 times x. Negative x. Negative 1 times negative 1. Positive 1. Negative 1 times I. Negative I. Positive I. Once again, do you guys understand what this represents down here? I'm just doing each term, but then I'm stacking them so I can combine like terms really quickly. Notice I put my x's together. Does that make sense back there, what I'm doing? I times x. Ix. Gone. If they're not gone, you did something wrong. I times negative 1. Negative I. Gone. I times negative I. Negative I squared, but what's I squared? Negative 1. So negative 1 times a negative becomes a positive 1. So this comes out to be x squared minus 2x plus 2. I'm not done yet. Keep going. So what are we going to do now? Distribute it through. So I get x cubed minus 2x squared plus 2x minus 3x squared plus 6x minus 6. So therefore I get x cubed minus 5x squared plus 8x minus 6. There's my polynomial. How can I check that that's a polynomial? That is the one that I needed. Find the zeros by using the ones that we already showed, right? That we already know are. You guys know you can do synthetic division with imaginary? You want to see it? Hey, we are, because I was going to show it anyway. We still got time anyway. Okay, so here we go. What's the coefficients here? 1, negative 5, 8, and negative 6. What was one of our zeros that were imaginary? 1 plus I. How about that one? Does that work? And how much do I take up of your view? Quite a bit?
Yeah,
Just like this side over here. I'm trying. I'll try step over more. Okay, here we go, watch. Okay, I'm gonna do this in my head though, so bear with me here. 1 plus I times 1 is 1 plus I. Negative 5 plus 1 is negative 4 plus I. That one's pretty simple. So here we go. 1 plus I times negative 4 plus I. Here's it in my head. 1 times negative 4 is negative 4. Is everybody there with me? 1 times I is I. Minus 4I. What's I minus 4I become? Minus 3I. I times I squared. And I had negative 4 minus 1, so that's negative 5. Add those together, what do I get? Now notice, could you guys necessarily do what I just did there in my head? No, because I've practiced this a bajillion times and I kind of know how to think about what's coming there, right? So you might have to do the little work off the side. 1 plus I times 3 minus I. Here we go. 1 times 3. 3. 1 times negative 3I. Negative 3I. I times 3. 3I. Negative 3I and 3I are gone. So I still have my 3 here, don't I? I times negative 3I. Negative 3I squared, which becomes 3. 3 plus 3 is 6, which is 0. Notice it shows it's a factor. Interesting, huh? The second one's really easy, though. The first one is a little hard, but the second one, watch, it's not 1 plus I. What would it be on the second one? 1 minus I. Watch how easy this guy is, though. 1 minus I times 1. 1 minus I. 4 plus 1, negative 3. 1 times negative 3. Negative 3 plus 3I is 0. So first off, this was x cubed, was it not? So what's this guy? X squared, what's this guy? So there's the last one, where I already had these guys as 0. Okay. So did I just prove the thing that I multiplied through came from the zeros that I had? Do you have to do that? Could you if you wanted to make sure you got answers right? And make sure you do it within the time frame of the test, which is 1 classroom page. Any questions? No. You good? Down the road? I'm looking, I'm trying to look for eye contact. You good? Denise, we're good? Okay. Ryan's not looking at me. You good? All right. Rafe, you ain't looking at me either. You're not giving me that eye contact. If yes, I'm good. Thank you. Boom, boom, boom. Riley. Kaya. Did I get it right? Okay, that's it, guys.